you're subtracting fractions, it's very similar to adding. The one thing you want to remember is you probably want to go back to when you used to add off. When there's a minus sign, you want to change it to addition and take the opposite of what's there. So just change that to plus a negative 2. Now here we want to get a common denominator. Our bottom ones are already factored. 2x minus 5 doesn't factor any further, so I put parentheses around it. 5 minus 2x doesn't factor any further. Well, I would just multiply them, except that I noticed they're opposites. So I could factor out a negative out of one of them. So I'm going to factor a negative out of the second one. The first one's going to stay the same. The second one's going to become negative 2x minus 5. We've talked about this quite a bit. It doesn't matter where this negative is. So instead of trying to multiply the first one by a negative to make it the same, I'm just going to multiply the top part by that negative. Well, what's a negative negative 2? Well, that's positive 2. So the first one doesn't change. But this becomes, instead of plus negative 2, it's going to become plus positive 2 over 2x minus 5. Now we can go ahead and combine our like terms. We get x plus 2 on the top, 2x minus 5 on the bottom. We look to see if that simplifies, which it doesn't. You go ahead and box it in. You're going to see a lot of these. Look for those flip-flops. Oh, there were going to be more down here. All right, this one's going to be a little bit more involved. We see again that it's subtraction. So when I add up, this is really in parentheses. So I need to apply that minus sign to everything that's up there. So I'm going to change this to plus. This becomes negative x squared, positive 4x, and positive 19. Now I need to factor x plus 5. My denominators, x plus 5 doesn't factor, so it gets a set of parentheses. The second one's a trinomial. To get x squared, we have x and x. Our signs are the same. They're both addition. I'm looking for factors of 15 that have a sum of 8. There we go, x plus 3 and x plus 5. Now, like I was telling you before, when you have groups of binomials that are being multiplied, when you look for your GCF, you want to write down, what do they have in common? An x plus 5. I go ahead and I mark that out just so it's out of my mind, and then I look for what do they have that's different. Well, the second one had an x plus 3. So that's also part of our denominator. Now looking at the first fraction, it only had the x plus 5, so it needs the x plus 3, which means I need to multiply the top by x plus 3. The second one already had both pieces, so its numerator is going to stay exactly the same. First one I need to FOIL. I get 2x squared minus 3x plus 6x minus 9. So that's 2x squared plus 3x minus 9. And the second one is negative x squared plus 4x plus 19. Watch your signs on these. Now we're going to go ahead. Our denominators are the same, so we're going to combine like terms. 2x squared and negative x squared is x squared. 3x plus 4x is 7x. And negative 9 plus 19 is positive 10 over x plus 5, x plus 3. That would be our final answer, but we know we need to check it by seeing if it simplifies. This one's not quite as obvious. It looks like that top will factor. The signs are the same. They're both addition, so I'm looking for a sum of 7. 1 and 10, 2 and 5 will work. So it factors to x plus 2 and x plus 5. And on the bottom I have x plus 5 and x plus 3. Now it looks like this does simplify because we have an x plus 5 on the bottom and an x plus 5 on top. We're left with x plus 2 over x plus 3. These problems could ask for restrictions. At this point, for most of them, we're not going to worry about restrictions. We'll leave that for other problems. We were going to focus on just adding and subtracting. Here are several problems for you to try. And be sure you bring those to class so we can go over them.